Question 6, just 2 questions to go. So a roller coaster is constructed by joining sections of track. Equations are used to design each section of track. The side elevation of the first section of the roller coaster is shown on the graph. X is the horizontal distance from the start, and Y is the height of the track. So you can just imagine that this is the start of the roller coaster where it will just go up, and then probably get to a nice big drop and go woo, and then maybe a loop-de-loop, you never know. So we need to find the equation of the line between 5 and 38. So the first thing that we need to find is a couple of coordinates. I am pretty happy with one in here. That was a nice one. So that is 17. And then we go across 17, 13. And then there's another one just here, which is quite nice. 32, 25. So if you find them where they cross the grid lines, you then get to deal with integers rather than having to deal with decimals. Okay, so to find the gradient of this, we just do y2 minus y1 over x2 minus x1. So that's the second y coordinate, take away the first y coordinate, and it's the second x coordinate, take away the first x coordinate, which gives me 12 over 15, and that simplifies to 4 over 5. So my equation is going to be y equals 4 over 5 x plus c, which is a constant. Now, all I need to do in order to find this out, what this c is going to be, is to substitute one of the coordinates in. So I'll use the smaller values. With 13, and then that equals 4/5 of 17 plus the constant. Right, 4/5 of 17. 17 times by 4 divided by 5 is 13.6. And when we subtract, we're going to get negative 0.6. 13 take away the answer. Is negative 0.6, which therefore means our graph will be y equals, and I'm going to turn this into 0.8x take away 0.6. Part B, the next section of roller coaster track is a downhill section. The side elevation of this downhill section is shown on the graph below. Which equation represents the downhill section of the track? So we've got 3 cubics. It's important to try and consider what a cubic looks like. So we've got 2 positives and 2 negatives. First thing I will point out is this crosses the graph at positive 32, which means that it can't be that one and it can't be that one because they have negative 32 as their y-intercept. So the shape of quadratics, if we've got a positive quadratic, it would look like that. And if we have a negative quadratic, it would look like that. I'm saying quadratic, and it's cubics. Sorry, team. So the cubics. Now with this bit here, we can see that we've got a turning point at the top, and we're going into a turning point at the bottom. And I can't really identify, because actually this is not drawn great. The sketch here would go down, up, down like that, and it would continue having a steeper gradient. Now this is curving off, which kind of makes it look like this section between here and then in here, which then leads me to believe that that's going to be a positive cubic, and therefore I would suggest that it is the first graph. Finally, roller coaster riders experience vertical g-force. When vertical g-force is greater than 1, riders feel heavier than normal. The graph below shows the vertical g-force that roller coaster riders experience over a 70-metre section of track, where x is the horizontal distance from the start of the section. Estimate the time in seconds the rider will feel heavier than normal during this 70-metre section. So we're looking for where that g-force is greater than 1. So the g-force, I don't know whether we're including 1 here. I don't think we are. So it's going to be about there, which is at 23, I think it's 23.5. So 23.5 until we get up to 70. So the distance in meters, estimate the time, what's the time? So 70 take away 23.5. Let's find that distance. probably worth a mark. 46.5. Assume that the roller coaster travels at a constant horizontal speed of 12 meters per second. And I need to estimate the time, speed, distance, time. I've got my distance, I've got my speed. So 46.5 divided by the speed will give me the time. And that is 31 over 8, which is 3.875 seconds. Right, that's question 6 done. I'll see you at question 7. One more question to go, and then our recording is done for the day.